And welcome back to for final maths class. Today we are going to look at another topic under mathematics called partial fraction. Okay, and with the partial fractions, you know, previously we dealt with rational function or rational fractions where you have two different functions dividing each other. Okay, so how to deal with them, and we did justice to them. Okay, but with this we have partial fraction, and with the partial fraction it has to do with you have two different functions which are adding or subtracting one another. So how do we deal with that? And then with the partial fraction too, we have them in types. Okay, we have about 4 types of them, and today we are going to look at the first type, and then the second type, and the fourth types. Okay, the third and fourth type. Okay, so we are going to look at all the types, and we are beginning with the type 1. With the type 1 of the rational function is where you have the denominator of the rational fraction to be a linear denominator. With that one, if you have them, then when you are equating that particular function to a certain constant, the constant will be either a or b. Okay, just like we have in this equation here, the denominator or these factors under the 6, which are the denominator, are of linear functions. Okay, they are not quadratic, or they are not occurring. All right, so the first thing that you have to do is to equate them to a constant, say a. All right, over, then you pick the first factor, all right, which is what, x plus 3. Then plus, you bring an additional sign, which is what, the plus. Then another variable, which is what, b, or another constant, which is b, over the second one, which is x minus 3. Okay, so after doing this, then you find the LCM. You know, we have a fraction here, another fraction, and another fraction here. So we can decide to find the LCM of these fractions. Okay, and the LCM of this fraction will give us the whole of this. All right, which is x plus 3, x minus 3. That will be the LCM. Then we use the LCM to multiply the whole of this fraction. We use the same thing to multiply the whole of this fraction, and we use the same thing to multiply the whole of this fraction. So when you look at the explanation that I just gave, if we should go by age, you know, we will cover all this board and then clean again for the same solution, and we will not be done. Okay, that will waste our time, and then it will take too much of the spaces on the board here. Now, so there's since we know that is what we have to do, and then we will know the results that we are going to arrive at. So what we'll do is we will take the numerator here, which is 6. Then we will equate it to, since the denominator or the LCM is this, when we use the LCM to multiply the whole of this, since it is s plus 3, s minus 3, the s plus 3 and s minus 3 will cancel 2 of this, and it will left with what, the 6. So we just write only the 6. All right, so we'll do the same thing here. This x plus 3 will cancel the x plus 3, which is at the LCM, and it will left with what, x minus 3. So a will multiply x minus 3. Then you bring your addition sign. Then b times x minus 3 2 will cancel the LCM, x minus 3, and it will left with what, x plus 3. So here will be what, x plus 3. All right, so now you have it in this way. Now when you get here, there are 2 methods that we can use to, you know, simplify this or to resolve this. And the first method is the cover up method. With the cover up method, what we do is we will look for a value which, if we set into this equation, it will set one of the constant 0. Okay, it will set one of the constant 0, or the other method is that we will expand this, and then we compare coefficient. Okay, we compare coefficient on both sides of the equation. Those that are constant, we co-equate them and then solve for the constant, and then those that are also with the variable x, we compare them and then we solve for them. So we will take the first one, which is the cover up method, which is very simple. Okay, there we will set one of the constant to 0. Okay, and by so doing, we will have to put x to a certain value, which will cause that particular constant over there to 0. Okay, so when you look at it, we can say when x is equal to, which one do you want to set 0? Let's say we want to set b to 0, so we will set x to be equal to -3. Okay, so here we have 6 to be equal to a into bracket -3 minus 3 plus b into bracket negative 3 plus 3. So here, when you look here, automatically minus 3 plus 3 will give us what? 0. So when minus 3 plus 3 gives us 0, it will multiply this b and it will set this b to 0. So b is gone. We've gotten rid of what? B. And here we will have a multiplying what? Minus 6. Okay, so 6 will be equal to minus 6a. Now we want our a, so we divide both sides by what? Negative 6. Okay, so this negative 6 will cancel this negative 6, and we will have a to be equal to negative 1. So here it will be what? Negative 1 over here. So after doing this, then we set the other variable to be equal to, to the other ones too. We will have to set a to 0. So we make x to be equal to what? 3. All right, since we set x to be equal to negative 3 to get rid of b, here we set x to be equal to positive 3 to get rid of what? A. So we will have 6 to be equal to a times 3 minus 3 plus b into bracket 3 plus 3. Okay, so we have 6 to be equal to 3 minus 3 will give us 0, and it will multiply in to give us what? 0 over there, plus 3 plus 3 will give us 6 times b. So we have what? 6b. We want b, so we divide both sides of the equation by 6. Okay, so this will happen. So we have b to be equal to what? 1. All right, so from there, then we will rewrite the whole of this, and then instead of writing the variables here or the constant here, we put the values of the constant over there. Okay, so we will have 6 over x plus 3 x minus 3 to be equal to a is negative. So to make the writing look nice, we have to bring that with a at the second at the other part, and then the b will come to the beginning. Okay, so we have b to be equal to 1 over x minus 3 here, then plus 1 over x plus 3 here. All right, so sorry, it will be minus here because we had minus for a, which is this. Okay, so this will bring us to the end of the type 1 of the partial fraction. So now we will quickly move to the type 2 of the partial fraction. Now quickly we are moving on to the type 2 of the partial fraction, and with the type 2 of the partial fraction, we will have, or you have one of the denominator, not one of them, the denominator to have a quadratic function in it. Okay, so with that one, instead of expressing it as a over 1 factor plus b over 1 factor, this is how we express that one. It will be a over the factor which doesn't have the quadratic function, okay, plus bx plus c over the quadratic factor which is x squared plus 1. Okay, so the difference is that with the type 2, you will have this in this way, okay, bx plus c, and then what? X squared plus 1, then over the x squared. So instead of writing here just b, or you write it as bx plus c. So that is how we express the type 2 part of the type 2 of the quadratic what? The partial fraction. Okay, so if it has a quadratic function at the denominator, over there you express it in this way. Okay, so now from there, then just like we did with that, you find the LCM, then you express this in the linear form. So we have x squared, 3x plus 1 giving us what? A times x squared plus 1 plus bx plus c multiplying this, which is x minus 1. Okay, so from here we can set any of the variables to 0, then we solve for the other variable. Okay, so now when we set x to say 1, okay, when we set x to 1, it will cause the whole of b and c to be what? To be 0. Then we solve for what? A. So here will be 3 times 1 plus 1 equal to a into bracket 1 squared plus 1. Okay, here will tend to 0, so I won't bother writing them. Okay, so here I will have 3 plus 1 to be equal to what? 2a. 2a, because a square will give a 1 square will give me 1 plus 1, so it will be what? 2a. Okay, so here I'll have 4 equal to what? 2a. Then when I resolve for a, my a will be equal to what? 2, because I will divide both sides by 2, and then a will give me what? 2. Now when I also set x to be equal to say 0, when I set x to be equal to 0, let's see, it will eliminate b. Okay, it will eliminate b, and then it will also eliminate B, and then it will be left with what? A and C. Because I have A already, I can substitute it in and then solve for C. Okay, so I will have 3 times 0 plus 1 giving me A here, because when I put 0 here, okay, it will be 0 square, which will give me 0, plus 1, which is 1. 1 times A will give me what? Just A. Okay, and then here when I put 0 here, it will cause this B to be 0. Okay, so here will be minus C, because when I put 0 here, it will be 0 minus 1, and it will be left with what? Minus 1. So when it is left with minus 1, that minus 1 will multiply this here, and I'll have what? Minus C. So here 3 times 0 will give me what? 0. So I'll have 1 equal A minus C, and I know A to be equal to what? 2. So minus C. Now I will move this C to this side because it is negative to be equal to, now it will be 2 minus 1, and then I will have my C to be equal to what? 1. So I will move this C to this side. It will be turned to positive, okay, and I'll move this 1 to that side, which will turn it to what? Negative. So it will be 2 minus 1, and I'll have C to be equal to 1. Now with the B, before we can find the B, we can set the variable, we can set S to any number which will turn A and then C to 0. So what we'll do is we will expand the brackets. Okay, we will expand the brackets. So I will clean here, and then so now we will take note that we have A to be equal to 2, and we have C to be equal to what? 1. Now we will expand the bracket, and then you see how we can solve for B in the solution. So here we will expand the bracket, so we have 3x plus 1 equal to, now A will expand this, so we have a x squared plus A here, then plus, now this will multiply that. Okay, so we have bx times this, we have what? Bx squared minus bx plus cx minus what? C. Here then we group like terms, or we group them based on the highest degree and then the constants. Okay, so we have here 3x plus 1 to be equal to, now with the x squares, we will factorize x squares out. So we have A plus B, then x square will be factorized out. So now from here to, we have the x's. Okay, we have x here, we have x here. Okay, so we will factorize x2 out. So we have this to be equal to C minus B into bracket x. Okay, and then the constants 2 will come. We have what? A plus C. Okay, so now this is what we do. Now comparing coefficients, we have x squared here. Okay, we have x squared here, and then we don't have x here. All right, here we have x here, so you can compare this with this. So you realize that when you compare x here and then x here, the coefficient of x squared here is 3. Okay, and the coefficient of x here is what? C minus B. Okay, so we know C to be equal to 1. All right, so 3 will be equal to 1 minus what? B. Okay, here I'll bring B here and then move 3 to this side, so it will be 1 minus 3. Okay, so B will give us what? Minus 2. Okay, so if you want to verify whether your answer is correct, we can also decide to use this x squared. Okay, here we don't have x squared, therefore when we are comparing, it means here will be 0, meaning we will have 0 to be equal to A plus B, which means that we don't have the value of what? X squared here, or we don't have anything that we can compare x squared with. Okay, so so x squared over here will give us what? 0, and then here to be what? A plus, because we are comparing coefficient. Okay, so now we have what? 0 to be equal to A, we have A to be equal to 2, so plus what? B. All right, so we'll move B to this side. Okay, oh sorry, we will move A, which is the 2, to this side, and then we have B to be equal to minus 2, which is the same as this one. Okay, so this will bring us to the end of the type 2 of the partial fraction. So what did we do? We just what? First of all, we express this in a linear form. Okay, because it is in a fractional form, so we find the LCM and express it in the linear form. So after expressing in the linear form, then we set the variable, which is the x, to a certain value, which will cause some of the constant to tend to 0, so that we can solve for the other constant. Okay, so after doing that, then the third constant, because we have 3 variables here, or 3 constants here that we need to solve for. Okay, so after solving for 2, which is A and C, the B, there's no way we can set the x to 0, or the x that will cause the A and C to 0, so we can easily solve for the B. So what we do is we expand the bracket. Okay, after expanding bracket, then we compare coefficients. So after comparing the coefficients, we have b to be equal to what, 2. Now we did that twice. Okay, we use 2 ways to find or to verify whether our answer is right or wrong. Okay, so from here you can also decide to repeat this. So we have a to be equal to what, 2, so we can put 2 here. We have b to be equal to minus 2, right? So minus 2. Okay, and we have c to be equal to what, 1. Okay, so over here I can write it as 1 minus 2x here. Okay, so this will bring us to the solution and to the end of the type 2 of partial fraction. Okay, so quickly we will move on to the type 3. Now we have the type 3, which has a repeated factor at the denominator. Okay, so with the type 2, it's not a repeated factor, it is what, a quadratic factor. Okay, it has a quadratic at the denominator, but with this one it has what, with the type 3 it has a repeated factor, which this is a repeated factor. Okay, so with that one, this is how we express it. It will be a constant a over the first one, which is not the repeated factor, plus b over, first of all we write what, one of the repeated factor. This repeated factor has to be minus 1. Okay, so it will be what, x minus 1, then plus c again over the repeated factor as well with the square on top of it. Okay, so from here, then just like we did with the first, we find the LCM and then what, you multiply through with the fraction. So here when you multiply through by the LCM will be this and that. Okay, you will multiply through, you have 1 here to be equal to, when you multiply it by this, you have a multiplying x minus 1 squared. Okay, plus b also multiplying x, one of this x minus, so it will left with what, x plus 2 then x minus 1. Okay, because it will take care of one of this. This is also part of the LCM. Okay, so it will take care of one of this. So plus c into bracket, the x, this squared will take care of what, this square, so it will left with what, x plus 2 here. Okay, now this will give us the expression. Okay, so now we will have to look for values of x, which can easily make us set any of the variables to 0, then we solve for the others. Okay, so looking at it very well, when I set x to be 0 and x to be 1, okay, when I set x to be 1, it will cause this will be 1 minus 1, 0 squared will give me what, 0. Okay, and then 0 multiplying a will cause the a to be what, 0. Here too, when I set x to be 1, the same one, it will cause here to be 0, and then it will multiply the whole of this to be 0, and then here will be 3, and then it will be left with what, just this. Okay, so now this is what we have. So when I set x to be equal to 1, okay, I'll have 1 here to be equal to, this one will tend to 0. Okay, this one will also tend to 0, and it will be left with what, c into bracket 1 plus what, 2. All right, so we'll have 1 to be equal to what, 3c. All right, so my c will be equal to 1 over 3. All right, so now we've gotten the value for c. Now let's see which one again. When I set x to be equal to minus 2, when I set x to be equal to minus 2 also, it will turn b to 0, it will turn c to 0 also, because here I'll have minus 2 plus 2, which will give me here 0, multiplying the whole of this will give me 0, and here too it will multiply and give me the c to be equal to 0. So from there I can solve for a. So when x is equal to minus 2, okay, I'll have 1 here to be equal to a into bracket minus 2 minus 1. Okay, so 1 will be equal to minus 3a, and my a will give me what, minus 1 over 3. Okay, so now we have gotten the values of a and then what, c. So now let's see how we can manage to get the value of b. So with the value of b, if we should do it, we will have to expand the brackets just like we did with the previous type 2 of the partial fraction. So we have a to be equal to minus 1 over 3, and we have c to also be equal to 1 over what, 3. Okay, so put it that one aside. Okay, so I will state that when x is equal to say 0, okay, I will have here 1 to be equal to, now when I set 0 here, it will give me 0 minus 1 squared. Okay, so it will minus 1 squared, which will give me what, 1. So 1 times a, I will have what, a here plus, when I set 0 here, okay, it will be left with minus 1. When I set 0, it will be 2 here, so 2 times minus will give me minus 2. Minus 2 times b here, I'll have minus 2b. And then here, when I set this x to 0, it will be what? 0 plus 2, okay? And here we'll be left with what? 2. So 2 times c, I'll have what? Plus 2c, okay? So now I have the value of a and I have the value of what? C. So I can just insert in and solve for the value of b directly, okay? So a is equal to minus 1 over 3 minus 2b plus 2 times 1 over 3 here, okay? So from here, I can go forward and write minus 1 over 3 minus 2b plus 2 over 3. Okay, so I'll move this one here and I'll move the rest to this side. So I'll get it easy to solve. So I'll have 2b equal to, I've moved here this one 2b to this side, okay? So 2b will be equal to 2 over 3 minus 1 over 3 then minus 1. Okay, here the LCM here is 3, so I can use 3, or better still, before that I can decide to operate these two. Okay, since this one is over 3 and over 3, it will be easy for me to simplify them. So it will be what? 1 over 3 minus 1. Okay, so LCM is 3, so here I'll have 3 will multiply 2, so I have here 6b equal to 1 minus what? 3. Okay, so 6b will be equal to minus 2, and I'll divide 2 by 6. I'll divide here 2 by 6. Okay, so now our b will be equal to, so 2 will go here 1 time, 2 will go here what? 3 times, so it will be minus 1 over 3. Okay, so now we have our a to be equal to minus 1 over 3, c to be equal to 1 over 3, and then b to be equal to minus 1 over 3. Okay, so the same process for all the types. Okay, the same process with the type 1, type 2, and then type